All right, I'm back and we're going to continue on problem 8. This is test 2B. We're going to finish up on page 1. And it says increasing the sample size has what effect on the margin of error? The formula sheet, the one that you'll be given for the exam, this is the formula sheet. Confidence interval, remember, contains the margin of error. So on a confidence interval, it's always your point estimate plus or minus your margin of error. So this right here is your margin of error. On your confidence interval for the mean, this part right here is your margin of error. We're dividing by n. So when you divide by a larger number, you're going to decrease the margin of error. And that should make sense because we want to if we increase our sample size, we would want to be more precise, and so our error would go down or would decrease. The next question says increasing the confidence level has what effect on the margin of error? And if we go back to our formula sheet, we can see what happens to our critical value as we go from 80 to 90 to 95. The numbers down here get larger. So as we go to 80 up to 99, these numbers get larger. That's this part of your margin of error right here. So as these numbers get larger, your margin of error would increase. Okay, so let's go down here. Type 1 and type 2 errors, those are always really hard for students. Let's review that. So for a type 1 error, that happens, it's an error. So we made, although we don't know we made a mistake, whenever you decide to reject or not reject the null, there's always a chance that an error has occurred. And so type 1 error means that you reject a true null hypothesis. That would be an error because the null hypothesis is true, then you wouldn't want to reject it. And a type 2 error is the opposite. So type 2 error happens when the null hypothesis is not true, but you don't reject it. Okay, so it happens when you don't reject a false null hypothesis. If the null hypothesis is false, then you would want to reject it. Maybe it would make more sense to say false rather than not true. So you don't have two double negatives. Okay, and so those are the definitions. We want to put it in context of the problem. So here's a null hypothesis where we're saying that mu is equal to 4, so the average lifetime of a battery is equal to 4, and then the alternative is that it's less than 4. And so a type 1 error would mean that we reject a true null hypothesis. So we're rejecting the null. And if we reject the null, then we're going to conclude the alternative. So for type 1, we would reject this and conclude the alternative. So a type 1 error occurs if we conclude that the mean battery life is less than 4 when in fact it is not. And so that would be a type 1 error. And so the answer would be A. Because we conclude the alternative, but the null is actually true. Okay, and then a type 2 error, we would conclude that the null is true when in fact the alternative is true. So type 2 error means the null hypothesis is false, but you don't reject it. So we would conclude that the mean battery life is 4 years when in fact it is less than 4 years. So the C, for some reason, is up there, but the third answer is the correct one. Okay, so those are very hard for students, and so you might want to take another look at that, make sure you understand it. But we'll go ahead and move on. So the next question is, according to a Gallup poll, about 73% of 18 to 29-year-olds said that they were registered to vote. A professor asked her students whether or not they were registered to vote. A sample of her students, 35 said that they were. And we want a confidence interval for proportion. Okay, so keyword here is proportion. And if you like to use the calculator, you go to your formula sheet. The calculator function is actually on there. We want a confidence interval for proportion. And so here's our formula right here. We're going to do that, and we can also use the 1 prop z interval. So this will be given to you, but you will have to know how to use it if you like the calculator functions. Okay, so we'll do it both ways. The first thing we need to do is calculate p hat. And so 35 of the 50 students said that they were registered to vote. So that's equal to 0.7. Now I just want to use that formula on the formula sheet. This formula right here. All I need is z, my value for z, but for 95% is 1.96. Okay, so I take p hat, which is 0.7, plus or minus 1.96. And then I take the square root of 0.7 times 1 minus 0.7, that's q hat, divided by our sample size, which is 50. And from that I get the interval. I get my lower bound of 0.573. And then my upper bound of 0.827. Okay, and then if you prefer the calculator function, I can go to stat and then tests. And then for a confidence interval for proportion, it's letter A. So go down to let's go down to letter A, hit enter, and then I just need to enter the correct information. So my X is my count of successes, and so that's going to be 35. And then 50 is my sample size, and my confidence level is 0.95. And then I just hit calculate. Okay, so here's my confidence interval. It goes from 0.573 up to 0.827. That's my confidence interval. It's what I got when I did it by hand. All right, and you almost always have to interpret a confidence interval. This is a confidence interval for proportion. It's a 95% confidence interval, and it represents the proportion or the percent of students, of her students that are registered to vote. She took a sample of 50, but she wants to make the confidence interval for all her students. So we are 95% confident that between 57.3% and 82.7% of her students are registered to vote. All right, and so the last question for the last part for this question goes over that other figure, the 73%. So this is pretty common. She wants to compare her students to the national percentage. And so 73% is the national percent of young adults that are registered to vote. And since the confidence interval captures 73%, then that number is consistent with the confidence interval. So we can't say that her students are any different than the national trend. Okay, so this is a pretty common question. If that 73% was really small, let's say 45%, then we could say that a bigger percent of her students vote than the national average. But it's not, it's 73%. So what you want to do is just see if that value is inside the confidence interval. All right, so let's move on to the next question. According to the U.S. Department of Transportation, the mean gas mileage of passenger cars was 21.2. A researcher wanted to test the claim that the gas mileage has decreased since 2009. He found that a random sample had a sample mean of 19.95. So sample mean of 19.95 means that X bar is equal to 19.95. Let's see. Okay. So X bar equals 19.95. That doesn't mean we're going to use it in the question, but let's just point that out. Here's another question where we're going to identify the null and alternative. The null and alternative will have a parameter in it, not a statistic. Remember, X bar, because it comes from a sample, is a statistic. So X bar will never be in your null and alternative. And so we can eliminate A and B right off the bat. And so it's either going to be C or D. Remember, the sample mean never goes into your null or alternative. So 19.95 will not be in the null or the alternative because it represents your sample data. Your sample data never goes in the null or the alternative. The number that goes in there is some status quo or some past figure that's given to us kind of on its own. It didn't come from data. It's just some figure that was known maybe in the past. It's what we want to compare our data to. Our data was the 19.95, and we want to compare that to the past value of 21.2. So the correct answer is D. So one thing to remember that X bar never goes in the null, P hat never goes in the null or alternative, and your sample data never goes in the null or alternative. Okay, next one. The p-value for the above test is 0.35. Using a significance level of 0.01, give a 1 or 2 sentence conclusion for the hypothesis test in context of the problem. Okay, so let's go all the way back up to page 1 again. And remember, p-values less than alpha level we reject. P-value greater than alpha level we fail to reject. And so our p-value was 0.35. That is greater than our significance levels or an alpha level. So the p-value is greater than 0.05. And so I could start out by saying that we fail to reject the null. Okay, so that's fine. You'll get some points for that. Our p-value is greater than 0.05. But what does that say about the problem? Remember, what's he trying to do? This researcher wanted to test the claim that the gas mileage has decreased since then. He either found evidence for that or he did not. And if we're not rejecting the null, that means that we have to go with whatever the null says. And so I always word it in context of the problem by just answering the question. Sorry, I have to start another box. So we failed to reject the null. Therefore, we did not find evidence that gas mileage has decreased since 2001. Okay, so notice what I did here. We're looking for evidence to test the claim that the gas mileage has decreased. If you don't reject the null, then you don't find that evidence. If you do reject the null, then you find that evidence. So because we didn't reject the null, I just insert did not rather than did. If you don't reject the null, then you don't find that evidence. All right, so this is a good place to pause, and I'll go ahead and start another video after this. See you in a few.